Hi students, in this class we see about electric flux for uniform electric field, right? So we know that electric field is uniform when it has constant magnitude and flows in the same direction. You see here all the fields are flowing in the same direction and it has constant magnitude. So it is uniform electric field. Electric flux is nothing but the number of field lines passing through a area which is kept perpendicular to the electric field lines. So this area is kept perpendicular to the lines. How many lines are passing through that will give electric flux pi e. The main point is it should be kept normal or perpendicular. Right, we know that pi is equal to EA. In the last video we have derived in vector form pi is equal to E dot A. How this E dot A has come we are going to see in this video. Right, so let us see that. Before that we may ask one question, what is area? A is a area. How area becomes a vector? Right? So we know that area is a scalar, but how it has become vector here when you just ask the area, we can say it is 5 centimeter or 100 meter square or 2000 square feet. But in which direction your area is looking? For example, take this tumbler, right? The mouth of the tumbler is looking up. So this is looking up. When I ask what is the area of the tumbler which is looking up, that means it is in normal vector, surface normal. Now the area becomes vector. Because my question is what is the area of the tumbler which is looking up. I introduce the term looking up direction, so it becomes area. So we know that any vector can be represented in terms of its magnitude and unit vector. So area magnitude is A only, but direction is given by unit normal n cap. N cap is unit normal. Unit means it is magnitude of 1. Normal means perpendicular. That's why it is known as unit normal n cap. It is always perpendicular to the area. So A vector, area vector is in the direction of normal vector. That is very important. A vector is in the direction of normal vector. This concept we are going to use now. Please understand. So similarly, suppose if you keep your tumbler upside down, what happens? Now the unit normal goes in this direction, so area will also go in this direction. Please remember A and n cap are in the same direction. A vector and n cap vector, unit normal. Right, now we go to the condition. See, first condition, as they always say, how to find the electric flux? Number of lines passing through an area which is kept perpendicular to the electric field line. Here the magenta lines are electric field lines, are uniform because they are flowing in the same direction. This is the area. I keep area perpendicular to the electric field lines. So case 1 is area is kept perpendicular to electric field lines. This is case 1. When I keep electric field lines perpendicular to, area perpendicular to electric field lines, how many lines are passing through the area? Maximum lines of passing through the area. So number of lines passing through area when it is kept perpendicular to the electric field is known as electric flux. So pi E is maximum. That is given by E into A. Area into number of electric field lines. That's what we studied in the last video. Right? Now you see in which direction area vector will be. Area vector is a vector which is perpendicular to the surface. It is a normal. So I told now only this is a perpendicular unit normal. So area will also go in this direction. So area is in this direction. Electric field is also in this direction. So you see electric field and area are parallel. Area vector are parallel. Right? So when these two vectors are parallel, what is the angle between E and A? 0 degree. Right? So what is the flux? Maximum of flux. Right? So pi E maximum, that is equal to EA. That is equal to maximum. This is case 1. Right? Now we go to case 2. Here what happens? Here the surface is parallel to the electric field lines. So case 2, surface is kept right parallel to E lines. Now what happens? How many lines are passing through the surface? No lines are passing through the surface. Since lines are passing through the surface is zero, electric flux is also zero. Right? Now you see electric field lines goes in this direction. N vector goes in this direction means A also goes in this direction I told. So E and E in this direction, A is going in this direction. So E is perpendicular to A. What is the flux now? Pi E is equal to, pi E is equal to 0. No flux is crossing. Theta EA, angle between E and A is 90 degree. Here, this case 2. Now we go to case 3. Now you see, now the surface is not either parallel, it is not perpendicular, it is slanting. Area is kept slanting, neither parallel nor perpendicular to electric field. So what we are going to do now? So if it is parallel, we get pi e 0. If it is perpendicular, we get pi e is maximum. Since it is neither parallel, it is lying between parallel and perpendicular, pi e lies between 0 to maximum. X or no? EA. Maximum value is EA. Right? So angle, we know it is what is the angle between E and A? Angle between E and A, right? If surface is perpendicular, angle between E and A is 0 degree, right? If it is parallel, you see first condition, surface is perpendicular means angle between E and A is 0 degree. Second condition, surface is parallel means angle between E and A is 90 degree. But it is neither slanting nor perpendicular, neither perpendicular nor parallel. So angle lies between 0 to 90 degree. Theta EA. Right? Okay. Now we see that. So what is the value of EA that we have to find? Pi E value we have to find. For this one it is 0. It is maximum EA. If angle lies between 0 to 90, in between 0 and 90, what is the value? If you want to find that, you see this is electric field lines passing through this surface. I take one example. We can solve for other electric field lines like this. Right? It is neither perpendicular to area. Area is neither perpendicular to this electric field nor parallel. So what I want to do is, I want to find the component of electric field which is parallel to the area and perpendicular to the area. Right? So we know that any vector can be split into two vectors. You see, this is A, this is C, means we are studying vector addition AB, BC. Right? So AC vector is equal to AB vector plus BC vector that we study. So this vector can be split into one adjacent component, one opposite component. If this is theta, this is adjacent component of this vector AC. BC is the opposite component of this vector AC. So similarly, for this E vector, I find adjacent and the opposite. Why I am finding adjacent opposite? Let me tell you soon. So if it is theta, this is opposite side. So this is also opposite side. Both are same length. This is adjacent side. This is also adjacent side. First we find opposite side. Which component is dealing with opposite side when you are having a triangle and theta? Opposite side is dealt by sin theta, because sin theta is equal to opposite by hypotenuse. Fine. So what is my opposite? I don't know. That's what I'm going to find. Hypotenuse. This E. This is E is my hypotenuse. So this implies opposite side is equal to E sin theta. Clear? So this is E sin theta means this side is E sin theta means this side is also E sin theta. That's why it was put like this. Next we find adjacent side. Who is dealing with adjacent? Cos theta, because cos theta is equal to adjacent by hypotenuse. Adjacent I want to find. Hypotenuse same E. So adjacent is equal to E cos theta. So here you see adjacent is E cos theta, right? So now we found that. You see how to draw unit normal vector. Unit normal vector should be always perpendicular to the surface. Here it will be like this. Here it will go like this. Right on here. So this is go like this. This area vector. This is what area vector. This is what area vector. But here you see electric field is going like this. But it is I cannot say whether it is parallel to the area or perpendicular to the area. So I split it into two components. Now we can forget this one. Instead we take this one. This is adjacent component of electric field. This is opposite component of electric field. You see this component is going like this. This component is going like this. Area is going like this. Area will be like this. So this area, sorry, this E and this A are parallel. That is theta is equal to 0 degree. So E and A parallel means what we get? E and A parallel. That is theta 0 means we get maximum. So E cos theta contributes to the maximum flux. That is the first condition. So it contributes maximum flux. What is that? That E is E cos theta, where E is equal to E cos theta. But you see this side here, E sin theta is in this side, but N, that is area, is going in this side. Both are perpendicular. So E and A are perpendicular. E and A perpendicular means what is angle? 90 degree. So flux is 0. So this component contributes nothing. So E sin theta contribution, electric field is equal to E sin theta contribution is 0. So I take only this component of electric field. So what is my pi? Pi is equal to EA, that we know. Instead of E, which is contributing, only E cos theta contributing, A, that is equal to EA cos theta. Right? This is the answer for third one. So we have three conditions. I make it. First one, area. How I am keeping the area position. Relationship between E and A vector. Angle, phi. See, first I kept area perpendicular. What happens to angle? 0, E and A are parallel. Angle becomes 0 degree. Pi E becomes maximum, that is equal to EA. Next I kept area, second case parallel. E and A becomes perpendicular. Theta becomes 90 degree. What happens to flux? 0. Now I kept slanting. Theta lies between 0 and 90 degree. So phi lies between 0 and maximum. Right? Sorry. 0 and maximum is EA. Clear? So this is what we made. Now we find the reason for why pi is equal to E dot A. EA vector. You take first condition, what is the angle? Angle between E and A, theta, 0 degree. See, for example, suppose pi is equal to E dot A, if you put E dot A is equal to EA cos theta is angle between A and B. What is the condition for theta A and B? 0 degree. That means EA. I hope first condition is fulfilled. Second condition, EA, theta now 90 degree, cos 90 0. So 0. Second condition is fulfilled. Third one, theta lies between 0 and 90. When theta lies between 0 and 90 degree, cos theta lies between 1 and 0. Yes or no? Cos 0 1, cos 90 0. So for all the things, the area value lies between 0 and maximum, because theta 0 maximum, 0 theta 90 maximum, minimum. So this concept, this full table is simply expressed by pi is equal to E dot A. That's why we are saying in vector form, because area is a vector. because position of the area is very important in electric flux. So I want to represent A in terms of, sorry, area in terms of vector. So flux in terms of area vector is given by E dot A. Scalar form pi is equal to simply EA. That's it. I hope you understand the concept very well. If you are having any doubt, please ask me in comment section. I will clarify all your doubts. Thank you.